Section 13.2, line integrals, video 7. Let's do another line integral with respect to x and with respect to y. In fact, you'll notice that this is the exact same line integral we had set up before. Y squared dx plus x dy. This time, however, we're defining the curve C as the parabolic arc along the equation x equals 4 minus y squared from the point negative 5, 3 to the point 0, 2. If you're really paying attention, you'll realize that this curve, this path, has the same initial and terminal points as the one in the previous video, where we just did the line segment. Does that mean we'll get the same answer? Let's find out. First, we need to parameterize this. X of t equals and y of t equals. In this case, we have x as a function of y. And if we have x as a function of y, we can just define y of t to be t, and then x of t to be 4 minus t squared. That makes sense. Y is equal to t, so x is equal to 4 minus t squared. But we need an interval of values. Since our parameter is being defined basically as the y-coordinate, we just need to arrange our parameter from the lowest y-coordinate to the highest y-coordinate. So negative 5 is less than or equal to t is less than or equal to 2. So we start here and we go up there. So let's evaluate this integral and see if we get the same answer. So we're evaluating it from negative 5 to 2, since we're basically defining our parameter as y. Make my t a little better there. We're replacing y with what it equals, which is just t. So t squared. Now we need to take the derivative of the x function with respect to t. The derivative of this is negative 2t. Negative 2t dt plus the x function, which is 4 minus t squared, times the derivative of the y function. Well, the derivative of the y function is just 1 dt. Don't see any trickery where I can factor stuff out, so we'll just have to attack this head on. Integral from negative 5 to 2. I can pull the dt out. This first term is going to be negative 2t to the third plus, distribute the 1. I feel silly saying that. 4 minus t squared. No like terms to combine, so let's just go to it. The antiderivative of negative 2t to the third is negative 2t to the fourth over 4. Wait, that's just negative 1/2. So negative 1/2 t to the fourth plus the antiderivative of 4 with respect to t is 4t minus the antiderivative of t squared with respect to t is 1/3 t to the third. And this is going from negative 5 to 2. And I will have to evaluate both of them. Neither one annihilates the antiderivative. So let's substitute the 2. Let's do this efficiently. 2 to the fourth is 16, times negative 1/2 is negative 8. 4 times 2 is 8. Those will cancel. Minus 2 to the third is 8, times 1/3 is 8/3. Minus negative 5 to the fourth is 625, times negative 1/2 is negative 625 halves. 4 times negative 5 is negative 20. Negative 5 to the third power is negative 125, times negative 1/3 is positive 125 thirds. I'm going to go ahead and distribute the negative and cancel these 8s. So negative 8/3 plus 625 halves plus 20 minus 125 thirds. Let's go ahead and get a common denominator of 6 and put it all together. Double both sides of this, I get negative 16. Triple both sides of this, I get 1875. Hit this with a 6, I get plus 120. Minus, double both sides of this, I get 250. So if I pop all that together, let's see. I'll just get out a calculator. Now I get out a calculator. Multiplying, dividing, not a problem. Adding big positives and negatives, just don't fill up to it. So we got 1,729, which is not reducible, not divisible by 2, not divisible by 3. Is that the same answer they got? That didn't sound right. Well, they turned it into a mixed number. Oh, yeah. Improper fractions you don't like. Something plus 2 you're okay with. Hooray for consistency. Divide that by 6 and we get 288 and 1/6, which is not what they got. They got something different. I can hear some of y'all screaming, no, you screwed up somewhere. I see where I screwed up. Do you see where I screwed up? I do. It's way back here. I told you that the trickiest part about these is getting the parameterization correct. And my functions, my parametric functions are actually correct. What's incorrect is my interval of values. The parameter is measuring the y-coordinate. So lowest to highest y-coordinate. And what's the lowest y-coordinate? It's not -5, it's -3. It doesn't matter how good you are or how good you think you are. Anybody, professor, researcher, student, can make the most casual of mistakes. Luckily, I think I can do some minor damage control here. So let me erase everything that would have need to be changed. I have mail. All right, so I'm going to go back and do some damage control now. Glad I checked the answer in the book. -3 to the 4th power is 81, so this is -81/2. 4 times -3 is -12. -3 to the 3rd power is -27, times -1/3 is +9. So when I distribute the negative, I get 81/2 plus 12 minus 9. Why don't we just go ahead and call that 3? And now to get a common denominator of 6, I would have to triple both sides of this fraction, and that would make the top 243. And for the 3, I would just have to multiply it by 6 to get 18. And so 18 minus 16 is 2, added on to 243 is 245, and that is 40 5/6, which is the answer they had in the back. So 2 lessons. Number 1, don't be so cocky to think that you can never make a mistake. It doesn't matter how good you are. Number 2, the path mattered. On the previous example, when we took the straight line path, we got a value of -5/6. But when we took this parabolic arc, we got a different one. Now, there are instances where the value of the line integral is independent of the path and only dependent on the endpoints. But that's something that you'll explore in the next section. It's called being path independent. All right.